Assalamualaikum and hello everyone. Greetings to my lecturer, Prof. Madya Dr. Nantini. Okay, today my group and I will present about the theory of continental drift versus theory of plate tectonic. Okay, we are unaware that the continent we live are on a moving. After all, it does not take 5 hours for 1 and 3 hours for the airline to go between Europe and Africa. The continents are nevertheless gradually moving with each other. In the early 20th century, a scientific idea called continental drift was developed to explain this move of continents. This concept was ridiculous at first, but it cleared the way for plate tectonic, a theory which scientists now acknowledge as a credible reason for how the continent of the Earth move. Alfred Wegener, a German meteorologist and geophysicist, discovered something strange when gazing over the world map. Wegener noticed that with the removal of the Atlantic Ocean, the South America and Africa continent would seem to fit exceptionally. And the two massive landforms would be well linked. He said that on continents separated by seas, similar fossils were found, suggesting that the terrestrial species were already linked. So this is the intro about this theory. So we go through for the next presenter. Thank you, Prof.
So today I want to tell you about the evidence that support the theory of continental drift and why it is not accepted by the scientific community. So first thing first, I want to tell about the continental drift meaning. Continental drift is a large-scale horizontal motion of continents that relative to one another and to ocean basins during one or more geologic periods. So the person who published this theory was a German meteorologist named Alfred Wegener. He published this theory in 1912, and he is the first person that developed this theory. So he proposed that there was only one continent in the ancient time, which is named Pangaea, and then it is based on a huge body of geology and paleontological evidence. And Pangaea slowly divided late in the Triassic period, which are about 251 million to 199 million years ago. The pieces started to drift away from one and another. In the ancient time, we only have one continent, which is Pangaea, and then after years, the continents started to drift away, and now we have 7 continents, all which is included North America, South America, Africa, Asia, Europe, Antarctica, and Oceania. So why this can be happen? So there are 5 evidence that support this theory, which is Alfred Wegener find this evidence by himself. So for the first one, the piece of the evidence that pointing to the existence of Pangaea is the distribution of fossils across the continents. So as we can see in this picture, this is the picture that show in the ancient time, which is Pangaea. So we can understand that the fossil of the animals in the ancient can be found in different continents. Like we can see, the fossil of animal can be the same animal fossil that can be found in South America and also the Africa. For another animals, we can see in 3 continents, which is Africa, India, and the Antarctica. So this evidence strengthen the theory of the continental drift. So second one, matching mountain ranges across the oceans. So in this picture, we have 2 parts, which is A and B. A is the current maps or nowadays map, and B is the ancient maps, which is the past time. So we can see in the B picture, the mountain in the purple color are very close to each other. Because of what? Because of we only have one continent, which is Pangaea. So that is why the mountain is so close and it makes like a one line. So after the theoretical theory of the continental drift, we can see that the mountains are divided into 3, which is in the North America, in the British Islands, and in the Caledonian Mountains. So this also the evidence to prove that the theory is true. So the third one, the glacial ages and climate evidence. So this evidence is affected by the glacial age and the climate changes in our world. So for the next one, which is the distribution of fossils such as Mesosaurus, this evidence is same as the first evidence, which is they found the same fossil of animal in different continent. But this evidence, it only stated about the Mesosaurus. So what I understand about this is the fossils were found in the continent of Africa and the continent of South America. In the past, we only have one continent, which is Pangaea. This further strengthens the evidence that says the continental drift theory is true, because we know that the animals in ancient time are very big and very large. So once a continent has been divided, we can find such a same animal fossil in other continents. So for the last evidence that prove this theory is true is the matching coastline on different continents. So in this picture, we can see that there are timeline, which is Paleozoic, Mesozoic, and Cenozoic. So in 245 years ago, like I stated before, we only have one continent, which is Pangaea. So we can see in this picture, 200 years ago, that is our world, Pangaea. 135 years ago, the continent started to be divided and only have 3 continents. 65 years ago, they started to be the same exact number like nowadays, but they have 8 continents with different names, and now we have 7 continents that I stated before, which is Asia, Oceania, Europe, and so many more. So these are the evidence that support the theory of continental drift that was developed by Alfred Wegener. So why it was not accepted by the scientific community? This is because Wegener's theory was largely dismissed, since he proposed no mechanism for repositioning the continents, and he believed that the power of the Earth's rotation was sufficient to cause the continents to move. But geologists understood this was not the case. They not trusted to the Wegener's theory. So the scientific community did not readily embrace the concept of continental drift. Wegener's view were so radical that he was frequently mocked, even though he gathered numerous pieces of evidence to support this theory. And the scientists eventually made further findings, and they resulting in the current theory of plate tectonics. So the scientific community did not agree with the Wegener's theory, so they made a further finding, and they found a new theory, which is the theory of plate tectonics. So this is why the scientific community did not accept the theory of continental drift.
Okay, I will continue the presentation, and I will talk about what are the evidence that support the theory of plate tectonic. So, plate tectonic is a concept that deals with the dynamic of Earth's outer shears, also known as a lithosphere, and is a revolutionized Earth science by having a consistent framework for understanding mountain building process, volcanoes and earthquakes, as well as the evolution of Earth's surface and reconstructing its previous continent and oceans. Plate tectonics is a hypothesis that is based on a wide range of geology and geophysical evidence. It is now visually generally recognized, and its acceptance marks as a real scientific revolution, comparable in scope to the discovery of genetic code in biology or quantum mechanics in physics. Plate tectonic has applied an overarching framework in which is to define the past geography of continents and oceans, the process controlling the creation and the destruction of landforms, evolution of Earth's crust, atmosphere, biosphere, hydrosphere, and climates, by incorporating the much older idea of continental drift as well as the concept of seafloor spreading. The concept of plate tectonic was formulated in 1916. According to the theory, Earth has a rigid outer layer known as a lithosphere, which is typically about 100 kilometers as 19 miles thick and overlays a plastic, which is a moldable, partially molten layer called the asthenosphere. The lithosphere is broken up into 7 very large continental and ocean-sized plates, 6 or 7 medium-sized regional plates, and several small ones. These plates move relative to each other, typically at rate of 5 to 10 centimeters and 2 to 4 inches per year, and interact along the boundaries, where they converge, diverge, or slip past one another. Such generations are thought to be responsible for most of Earth's seismic and volcanic activity. Although earthquakes and volcanoes can occur in plate interest, plate motion causes mountains to rise where plates push together or converge, and continents to fracture and oceans to form where plates pull apart or diverge. The continents are embedded in the plate and drift persistently with them, which over millions of years result in significant change in Earth's geography. Many continents have shapes that make them appear like jigsaw puzzle pieces. Consider the form of North and South America's east coast in comparison to Africa's and Europe's west coast. Many fossil comparisons around the border of continents that appear to fit together show species similarities that can only be explained if the two continents were once connected. So along the conjectured plate borders, there is also a lot of seismic, volcanic, and geothermal activity. For a 10-year period, here is where the epicenters of earthquake with a richer magnitude greater than 5.0 meter. They are rich where plates are separating as a rigid Atlantic ridge that are formed by lava wheeling up from between the plates as they pull apart. Mountain range are also being produced when plates are pressing against one another, such as Himalayas, which are still expanding. So we can conclude that plate tectonic is a manifestation of the underlying mantle convection regime, but the relationship between individual convection cells and plate borders is not straightforward, since plate boundaries are not permanent and change relative to one another like the plates. So the plate motion are primarily caused by gravity, with younger lithosphere being pulled toward destructive boundary by cold thick lithospheric slabs. The potential nature of spreading centers, which are raised to 2-3 kilometers above the average level of the abyssal plains, generates a less intense pushing force. Plate tectonic is a grand unifying theory of a science, integrating continental drift and seafloor spreading into a single holistic theory that explains many of Earth's fundamental structural characteristics. The idea has now gained scientific support to the point that to the movement of plates, both of relative to one another and to the hot spot reference frame. So it will be utilized to infer mobility of the hotspot reference frames in relation to Earth's rotating axis.
Different type of tectonic plate movement. The majority of movement take place in small zone between plates, where plate tectonic forces are most visible. The lithosphere, the Earth's outer shell made up of crust and outermost mantle, is split into patchwork of huge tectonic plates that move slowly relative to one another. There are around 7 to 8 main plates and several smaller plates. Along plate border, earthquake, volcanic activity, mountain building, and ocean trench development occur in zone ranging in size from a few kilometers to a few hundred kilometers broad. The Earth's outermost layer is made up of mosaic of thin flexible plates that move horizontally in relation to one another. Along the edge, plates interact with one another called plate boundaries. Okay, there are three main types of plate boundary, which is divergent boundary, convergent boundaries, and transport boundaries. Okay, the first one is divergent boundaries. Divergent boundaries are from along spreading center when plates are moving apart and magma flowing up from mantle crust. Imagine two massive conveyor belt transporting newly produced oceanic crust away from the rich crust facing each other, but slowly moving in opposite direction. Okay, there are two conditions of divergent boundary, which first one is on land. The divergent boundaries within continent initially produce rift, which produce rift valley. The second condition is under the sea, that the most active divergent plate boundary are between oceanic plates and are often called mid-oceanic ridge. The mid-Atlantic ridge is perhaps the most well-known of diverging border. These are underwater mountain range which stretches from the Arctic Ocean to beyond the southern point of America. It's just one part of the world encircling mid-ocean ridge system. The Atlantic Ocean has grown from a little inlet of water between the continent of Europe, Africa, and the Americas to the huge ocean is today due to seafloor spreading during the last 100 to 200 million years. Okay, the second one is the convergent boundaries. The sort of convergence that occur between plates is determined by the type of lithosphere involved. The convergence can happen between two oceanic plates, two mainly continental plates, or two primarily oceanic plates. The convergent plate boundary vary depending on the type of crust, which are the first one is oceanic continental convergence, second is oceanic convergence, and the third one is continental convergence. Okay, for the oceanic continental convergence, the subduction of the denser oceanic plate result in the formation of a mountain range on the continent. This sort of cohesion may be seen in the Andes. Many of the world active volcanoes, such as those in the Andes and the cascaded range in the Pacific Northwest are supported by oceanic continental convergence. Although the eruptive activity is obviously linked to the subduction, experts are split on the source of magma. For the oceanic convergence, island arc and oceanic trench occur when both oil plates are made of oceanic crust. Active sea floor spreading zone, treatment as backup basin, can also be found beyond the island arc. Submarine volcanoes are frequently linked with this when two oceanic plates converge, as in oceanic continental converge. One is generally subducted beneath the other, forming a trench. Okay, for example, the Marianas Trench, which run parallel to the Mariana Island, in where the fast-moving Pacific plate collide with a slower-moving Philippine plate. Okay, the volcano are formed as a result of the subduction process in oceanic plate convergence. So for over millions of years, erupting lava and volcanic debris pile up on ocean floor, becoming an island volcano when a submarine volcano rises above the seafloor. Island are generally formed by series of such volcano. Volcanic island are which run parallel to the trench, typically curved, as name indicates. The trench are crucial to understanding how island are like the Marianas and Aleutian Island develop, and why they are subjected to several earthquakes. Okay, the third one is continental convergence. It is one of the most apparent and stunning effect of plate tectonic may be seen in the Himalayan mountain range. When two continents collide head-on, neither gets subducted because the continental rock are relatively light and resist downward motion like two colliding icebergs. Instead, the crust buckle and is pushed upward or to the side. The Indian and Eurasian plate compiled up along the collision zone 50 million years ago when India collided with Asia. The following collision, millions of years of gradual continuous convergence of these two plates, drove the Himalayas and the Tibetan plateau to their current height. Okay, the last one is the transform fault boundary, or simply a transform boundary. It's the zone between two plates moving horizontal past one another. The Canadian geophysics postulate that transform fault are major fault of fracture zone that link two spreading center, which are divergent plate border, or less often trench convergent plate boundaries. On the ocean floor, the majority of transform fault may be located. They are usually characterized by shallow earthquake and offset the active spreading ridge, resulting in zigzag plate. The plate relative motion is horizontal. They can happen both underwater and on land, and they don't destroy or produce crash.
So what are the real world examples of tectonic movement? So as we know, plate tectonic is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movement. The theory, which solidified in 1960s, transformed the Earth's science by explaining many phenomena, including mountain building events, volcanoes, and earthquakes. The Earth has 7 major plate tectonic boundaries and 10 or so minor ones. Plate tectonic have deceptively slow movement, just centimeters each year, but they never die. Like seam of a baseball, tectonic plate boundaries wrap around the Earth. Earth's tectonic plate boundaries are unusual because they can consist of continent and ocean crust. Here are the 7 major tectonic plates of the world in a bit more detail. The first one, we have Pacific plate. Pacific major plate is the largest, which underlies the Pacific Ocean. Specifically, it stretches all the way along the west coast of North America to the east coast of Japan and Indonesia. This plate forms most of the Pacific Ring of Fire, which has some of the most violent and catastrophic earthquakes and volcanoes on the planet. And smack dab in the middle are the islands that make up Hawaii, the entire hotspot within the Pacific Plate is responsible for the volcanic activity that occurs at the Hawaiian Island. The second one, we have North American Plate. The North American Major Plate not only contains the continent of North America but also part of the Atlantic Ocean. This plate extends all the way over the North Pole and even contains Siberia and northern island of Japan. It also includes Greenland, Cuba, and Bahamas. The interior of the North American Plate contains a giant granitic crater. It is believed that the North American crater is 4 billion years old. The next one, we have Eurasian Plate. The Eurasian Major Plate consists of most of Europe, Russia, and part of Asia. This plate is sandwiched between the North American and African plates on the north and west sides. The west side has a divergent boundary with the North American Plate. The south side of the Eurasian Plate neighbor the Arabian, Indian, and Sunda Plates. It straddles along Iceland, where it tears the country in two separate pieces at rate 2.5 cm per year. On average, the Eurasian Plate moves about 1/4 to half an inch per year. The next one is African Plate. The African Plate contains the whole continent of Africa as well as the surrounding oceanic crust of the Atlantic Ocean. Oddly, it looks like a larger boundary of the African continent itself. The Somali Plate is positioned along the East African Rift Zone. This developing rift zone is gradually separating the east part of the continent. The west side of the African Major Plate diverges from the North American Plate. These divergent plate boundaries form the mid-oceanic ridge of Rift Valley. And then we also have Antarctic Plate. The Antarctic Plate holds the entire continent of Antarctica, including its surrounding oceanic crust. This plate is surrounded by parts of the African, Australian, Pacific, and South American plates. Antarctica was once grouped as part of the supercontinent Gondwana with Australia and India, but about 100 million years ago, Antarctica broke apart to its current location at the South Pole. It estimates that the Antarctica Major Plate moves about 1 cm per year. The next one, we have Indo-Australia Plate. The Indo-Australia Plate is a major plate combining the Australian and Indian plate, but they are widely considered to be two separate plates. The Indo-Australia Plate stretches from Australia to India. It also includes the oceanic crust from the Indian Ocean. The northeast side of the Australian Plate covers with the Pacific Plate. Australia, India, and Antarctica were once connected as the supercontinent Gondwana. As part of the supercontinental cycle, India drifts apart from moving northwest. Last but not least, we have South American Plate. The South American Plate is a major plate that includes the continent of South America and large portion of ocean from Atlantic Ocean. At the west side of South America, it experienced devastating earthquake due to covering plate tectonic boundaries, but the eastern edge lies in the Atlantic Ocean at a divergent plate boundary. Alongside the African Plate, these two plate boundaries pull apart from each other, creating some of the younger oceanic crust on the planet.
That's all for our presentation. Thank you, Prof.